Good morning to you. This is Ravi Kumar, working as Assistant Professor in the Civil Engineering Department from the PACE Institute of Technology and Sciences, Vallur. Today, we are going to see the analysis of trusses, the topic from the Mechanics of Materials course. Let us continue this topic. Today, we are going to see the analysis of truss topic from the Mechanics of Materials course. Okay. So basically, what do you mean by truss? Truss is nothing but it is a shelter where we can see generally we can observe in the parking areas and in the very large construction areas, buildings like that. So, and bridges we can see in different ways. Okay. So, coming to the analysis of truss, there are so many methods are there. So, for this analysis of truss, we are going to see the method of joints. From this method, we can learn how to analyze the truss by using this method of joints. There are few steps are there in this method of joints to analyze the truss. Number one is check the perfect condition and number two is calculate reactions by using equilibrium equations, and number three, draw the free body diagram, and number four, calculate the values. Okay, so these are the four steps involved to analyze the truss by using the method of joints. Okay, step by step we can see now. So what is the first step? Check the perfect condition. Check the perfect condition. So for this we are having the equation that is equal to m is equal to 2j minus 3. M is equal to 2j minus 3. Let us take a small one like this. ABC. Okay. So these are the joints. These are the joints. And these are the members. These are the members. AB, BC, AC. Those are the members denoted by M. And at A, comma C, comma B, those are the joints denoted by the letter J. So from this equation, how many members are there? 3 members. How many joints are there? 3 joints. So 3 is equal to 6 minus 3. 3 is equal to 3. This is perfect condition. Perfect condition. And if we add something like this, if we add something like this, let us look. A, B, C, D. How many members are there? 1, 2, 3, 4, 5. 5 members. How many joints are there? 1, 2, 3, 4 joints are there. So our condition is m is equal to 2j minus 3. So 5 is equal to 2 into 4 minus 3, that is equal to 5 is equal to 5. Okay. So if you draw like this, then the count will be increases, that is m is equal to 6 and j is equal to 4. 6 is equal to, so number of members are greater than the joints, then that is in not perfect condition. Okay, we need not to analyze by using this method. So these are the first step. This is the first step. We can see how to check the perfect condition by using this m is equal to 2j minus 3 equation. And next one is calculate the reactions. So calculate the reactions. So from the previous session, equilibrium equations. So here we can apply those things to calculate the reactions by using equilibrium equations. Those are sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. So as you know, sum of all the forces acting towards the right side is equal to sum of all the forces acting towards the left side. In the same way, vertical forces also, in the same way, moments also. By using these equations, we can calculate the reactions. Let us take the truss like this, carries the point load here, kilonewtons AB. So the reactions we can calculate, reaction at A, reaction at B, by using these equilibrium equations. This will be helpful. So next one is draw the free body diagram. Draw the free body diagram. So let us take a truss like this, and the force is acting like this, A, B, C. If you want to draw the free body diagram at this joint or A, look here, here the reaction RA at joint A, vertical reaction RA, and the force in the member, that is FAB, and the incline, this is theta. Okay. So if you draw the free body diagram here, and this will be like this. This is the force FAB. FAB, this is C. So FAC cos theta, FAC sin theta. So to resolve this force by using this inclination, okay. So this is FAC cos theta, this is FAC sin theta. Like this, you can draw the free body diagrams. So for each joint here, and last and final, we can calculate the what is the magnitude of the forces. Okay, what are the magnitude of the forces in these members we can see. So and final step, that is 4th one, is tabulate the values. So that is serial number, member, here magnitude, like this. Let us take the member AB. Okay, let us take the member AB. So in this, how much the value you get? Let us suppose 10 kilonewtons plus, that is in tensile. That is our assumption. Priorly, we can assume the members like this away from the joint tensile. If you get the negative value, let us take that is in BC, negative value, then 5 kilonewtons, that is in compression member. That's what we write here as a nature. This is tensile and this one is compressive. Like that, from these 4 steps, we can analyze the truss. Let us and we will see. This is 10 kilonewtons. This is A, B, C, and the distance is 5 meters. Okay, from this truss we will analyze the members. Okay, so this is a joint at A, joint at B, here at C. What are the 4 steps we have? To analyze truss by method of joints, we have 4 steps. First one is check the perfect condition, and second one is calculate the reactions by using equilibrium equations, and third one is draw the free body diagram at the joint, and fourth one is tabulate the values. Okay, so first condition, perfect condition. Okay, m is equal to 2j minus 3. How many members are there? 1, 2, 3. 3 members. How many joints are there? 1, 2, 3 at A, B and C. So this is in perfect condition. Okay. So next, calculate the reactions. We can get the reactions like this, RA and here RB. So we know from the equilibrium equations, sigma V is equal to 0, which states that sum of all the vertical forces acting towards upward is equal to sum of all the vertical forces acting towards downward. Okay. So here RA is in upward direction and RB is in upward direction. 10 kilonewtons is downward direction. RA plus RB is equal to 10 kilonewtons. Okay. So in order to solve this equation, we can take the moment at A. In the previous class we have discussed that. What do you mean by the moment? Moment is the force and perpendicular distance from movement center to the point of application of load. So if you consider the movements here, this is as a movement center. So this is acting in which direction? So if you keep here, this is in anti-clockwise direction. The force and perpendicular distance, that is 5 meters. So that is equal to RB into 5. That is in anti-clockwise direction. And here one force is there, that is 10 kilonewtons acting in clockwise direction, that is 10 into what is the perpendicular distance from here to here, movement center to the point of application of load, that is 2.5 meters. So that is equal to 10 into 2.5. So RB is equal to 25 by 5 kilonewtons. We substitute in equation 1, we will get RA plus 5 is equal to 10 kilonewtons, RA is equal to 5 and RB is equal to 5 kilonewtons. So RA is 5 kilonewtons, RB is 5 kilonewtons. So reactions we have calculated by using this equilibrium equations. Two steps we have completed. That is, number one is perfect condition in this. So number of members m is equal to 2j minus 3 number of joints. From this will be in the perfect stage. And second one is by using this equilibrium equations, sigma v is equal to 0 and sigma m is equal to 0, we can calculate the reactions. Two steps we have completed. And next one, we have to draw the free body diagram for this A, B, C. 10 kilonewtons, this is 5 meters. Let us consider at joint A, at this joint, at joint A. Okay. Here RA, that is 5 kilonewtons, and force in this member FAB. So this is 60 degrees and 60 degrees. The joint A, if you resolve this inclined force, that is FAC, okay, FAC, and the same value will be here, FAC cos 60, and this is FAC sin 60. Okay, did you get? So this is 60 degrees. By resolving this force into vertical and horizontal, this is FAC cos 60 and this one is FAC sin 60. This is the free body diagram of this. So here by using the same equilibrium equations, we can calculate by sigma v is equal to 0, RA which is in the upward direction plus FAC sin 60, that is also in upward direction. Okay, so these two are in the upward direction, that's why we have added. So what is the value of RA? We have calculated the previously, that is 5 plus FAC sin 60 root 3 by 2, that is equal to 0. So from this FAC is equal to, this will go this way, that is in minus and into 2 by root 3. Okay, kilonewtons. FAC, force in the AC, this value, the magnitude is 5 into 2 by 3. We have calculated from this free body diagram. Next, sigma H is equal to 0, which states that sum of all the horizontal forces acting towards is equal to sum of all the horizontal forces acting towards the left side. So here force in AB, right side direction, plus another force is there, FAC cos 60. FAC cos 60, that is equal to 0. Okay, so FAB value we don't know, but we calculated the FAC value. What is the value of FAC here? Minus 5 into 2 by root 3 into cos 60, that is 1 by 2, that is equal to 0. Okay, so by cancelling this one, FAB is equal to, it goes this way, 5 by root 3 kilonewtons, and the sign convention is plus. Okay, which states that this is in tensile stage and this one is in minus, which denotes that this is in the compression stage. Okay, like this FAB value and FAC value we have calculated. And coming to the final one, at the joint B, if you draw the free body diagram like this, RB this one, and this is FAB, and this is C. Okay, so this is 60 degrees. By resolving this, this is FBC cos 60 and this one is FBC sin 60. Okay, did you get it? So here the joint is B. If you draw the free body diagram for this, RB vertical reaction is there and the force in the member FAB is there and force in the member FBC is there. Okay, so force in the member FAB, force in the member FBC, which is inclined, and for that we can resolve into vertical and horizontal forces. So what is the horizontal force? FBC cos 60 and vertical force FBC sin 60. So from the equilibrium equation, same we have done here. Here also the same, that is sigma V is equal to 0, RB plus FBC sin 60 is equal to 0. RB value is 5, FBC we don't know, root 3 by 2. So FBC is equal to minus 5 into 2 by root 3. Okay, so like this we can calculate or we can analyze the member forces in the, okay, these member forces in these trusses. Okay, so and we can observe these two values FAC and FBC. So same value. Why? Because this is the symmetrical section and our portion is now to tabulate these values. Serial number, member and magnitude, and finally nature. Finally we should tabulate these values like this. First of all, ABC like this. So AC member, next one is BC member, next one is AB. Okay, what is the magnitude? Five into 2 by root 3. Okay, this value nearly 5.6 kilonewtons. Okay, so the nature is minus here, which indicates this is compressive. And next BC, this is also minus 5 into 2 by root 3, nearly the value is 5.6 kilonewtons. And AB is We have calculated, that is 5 by root 3, which is nothing but nearly 2.8 kilonewtons. So this is also compressive, and this one is tensile. Okay, so these are the values in these members. Okay, so like this we should analyze the truss by using the method of joints. If you look here carefully, so the value here in this member is same. Why? Because this is the symmetrical truss. This is the symmetrical truss. That's why. And in this member, the magnitude will be half, like this. So in the designing of these members, so we should go for the high values. Why? Because in the designing, the next stages, you can see that is equal to m is equal to sigma into z, m is equal to fz. So z is equal to I by y, where I is equal to, for the rectangle sections, bd cube by 12. So breadth and depth or thickness, okay, for this that is high, and for this is low. So in the designing, by using the moment equation, m by I is equal to sigma by y is equal to E by r, through that we can design. So for this case, we should analyze what is the magnitude of the forces in the members. So that's what the process to analyze the member. So this is the topic we can see in the mechanics of materials course, how to analyze the truss by using the method of joints. Thank you very much for giving me this opportunity. Thank you.